In this video, we're going to take a look at section 3.3, which is solving by the elimination method. So in section 3.1, we saw the graphing method. Section 3.2 is the substitution method. And now section 3.3 is the elimination method. Okay, so our objective in this section is we're going to solve systems of equations by using the elimination method. Now, it's the same type of problems that we've seen before, but we're just going to take a look at a different method for solving them. Now, the strategy here is first, you're going to write the equations in standard form, which is ax plus by equals c. So you'll get your variables on one side and the constant on the other side. And step 2, you're going to determine which variable you would like to eliminate. Then you're going to make the chosen variable terms opposites by multiplying one or both equations by appropriate numbers. Step 4, you're going to add the equations together and then solve the equation for the remaining variable. So after step 4, you'll have like x equal to a number or y equal to a number. So you have one of the variables solved for. Then with step 5, you're going to substitute the value for the variable that you solve for into one of the equations and solve for the other variable. Let's take a look at an example. Okay, so we have two equations. We have 5x plus 3y is equal to 17, and then negative 5x plus 2y is equal to 3. So now you have the choice of eliminating either your x's or your y's. Now, if we take a look at our x terms, it's a little bit more convenient if we eliminate our x's first. If you notice, 5x and negative 5x, these are already opposites of each other. So all we have to do is add the equations together. It's going to eliminate our x's. Okay. So 5x and negative 5x cancels out. Now 3y plus 2y gives us 5y. We have equal to 17 plus 3, which gives us 20. Notice the remaining equation, all we have is a y. There's no more x's. So let's go ahead and solve for y. Divide both sides by 5. We get y is equal to 4. So now we know what y is equal to. Now we have to figure out what our x is. So we're going to take y equals 4, and we're going to substitute that into one of the equations that we have. Okay? So let's go ahead and substitute it into our first equation. So we're going to plug in y equals 4 into 5x plus 3y equals 17. So we have 5x plus 3 times our y, which is 4. We have equal to 17. And now let's simplify. So we have 5x plus 12 equals 17. Let's continue now to solve for x. Subtract 12 from both sides. We get 5x is equal to 5. Now let's go ahead and divide both sides by 5. So we get x is equal to 1. Now we have our x solved for and we have our y solved for. Let's go ahead and write it as an ordered pair. We have 1, 4. And now we have our solution. Let's take a look at another one. So we have 4x plus 5y is equal to negative 8. And then 7x plus 9y is equal to 11. Okay. So now we can't just add the equations together and eliminate a variable. So for example, if we added these two together, we get 11x plus 14y is equal to 3. But none of the variables canceled out, which doesn't do us any good. So let's go ahead and choose a variable, and we'll get rid of that variable. So you can get rid of either your x's or your y's. Doesn't matter. At the end, you're still going to get the same solution. Now for this particular problem, I'm going to get rid of my x's. So first thing you want to determine, what's the smallest number that 4 and 7 can both go into? So in our case of 4 and 7, the smallest number is 28. You want one of those to be positive 28x, and you want the other one to be negative 28x. So I'm going to go ahead and make the top equation positive 28x. So I'm going to multiply by 7. And now you have to multiply each term in that equation by 7. So we have 28x plus 35y is equal to negative 56. And now the bottom equation, I have to multiply this by negative 4 in order to get negative 28x. So So go ahead and multiply each term by -4. We get negative 28x minus 36y is equal to negative 44. Now, once you have one of the variables to be opposites of each other, you can go ahead and add them. So 28x and negative 28x, those cancel out with each other. There's no more x's. 35y and negative 36y, we get negative y, equal to, now negative 56 and negative 44, we get negative 100. Go ahead and continue to solve for y. Divide by negative 1. We get y is equal to positive 100. Now let's go ahead and figure out our x. Let's solve for x. We have to plug in y equals 100 into one of those equations. So since the first equation has smaller numbers, I'm going to go ahead and plug it into that one. So plug it into 4x plus 5y equals negative 8. So we have 4x plus 5 times, and then our y, which is 100. And we have equal to negative 8. Let's go ahead and simplify. So we have 4x plus 500 is equal to negative 8. Subtract 500 from both sides. Okay, we get 4x is equal to negative 508. And now we're going to go ahead and divide by 4. And this will give us our x by itself. So we get x is equal to, so we're going to get negative, and then let's see what this divides into. So we're going to get 4 was in 5 once, 2 left over. Yeah, negative 552. Okay, let's go ahead and write it as ordered pair. You get negative 152, comma, 100. I believe I made a mistake with this one. Okay, so you get negative 127. Let's take a look at another problem a little bit more complicated. This time we're dealing with decimals. Okay, so previously in section 1.1, we saw equations that had decimals in it, but we learned a strategy to get rid of those decimals. And that strategy was to multiply by a power of 10. So let me, excuse me. So let me go ahead and get rid of the decimals in the top equation. So since I have at most 2 decimal places, I'm going to multiply everything by 100. So multiply everything by 100, I get 2x plus 3y is equal to 10. And now the bottom equation, the most decimal places I have is 1. So I'm going to multiply by 10 to get rid of those decimals. So I get 3x minus y is equal to 7. And now you go ahead and proceed just like what we did with the other examples. Let me go ahead and rewrite our equations down here. Okay, now let's choose a variable to get rid of. Now, if I wanted to get rid of my x's, notice 6 is the smallest number that 2 and 3 could both go into. But then I'm going to have to multiply both equations by a certain number. If I get rid of my y's, however, I have a positive 3y and I have a negative y. All I would have to do is multiply that bottom equation by 3. That's going to make my y's opposites of each other. So the first equation I'm not touching. I'm not going to multiply by anything. Now the bottom equation I'm going to go ahead and multiply by 3. So I get 9x minus 3y is equal to 21. Now we go ahead and add them together. So let's go ahead and add the equations. I got 11x, y's cancel out, I get equal to 31. Next step to solve for x, go ahead and divide both sides by 11. We get x is equal to 31 over 11. Okay, so let me just double check, make sure I did this correctly. I actually made a mistake right here. This should have been a 1. So the 100 times 0.01 gives us 1. So let me go ahead and make these necessary changes over here. So yeah, so we actually end up with a nice whole number. Okay, so this used to be a 10, I changed it to a 1, that's what it was supposed to be. Now 1 plus 21, I get 22. Now I divide both sides by 11. Okay, 22 divided by 11, I get x is equal to 2. Okay. Now we're going to plug in x equals 2 into one of our equations. So I could use one of the first two equations, but then I'm going to have to deal with decimals, so let's not use those ones. I could even use this one. Since this is just a modified version of the first equation, I could go ahead and use that one. So let's plug in x equals 2 into 2x plus 3y equals 1. So we get 2 times 2, and we have plus 3y equals 1. Okay, let's go ahead and simplify it. We get 4 plus 3y equals 1. Subtract 4 from both sides. We get 3y is equal to negative 3. And then divide both sides by 3. Well, we get the y completely by itself. We get y is equal to negative 1. So our ordered pair here would be 2, negative 1. Okay. So this was an example with decimals. First thing you'd want to do here is eliminate the decimals, so that way you're left with an equation, left with a system that's a lot easier to deal with. And then you proceed with it just the same way as the other two examples that we saw before this one. Okay. Here goes another one. This time we have fractions. Okay. So just like the previous problem when we had decimals, we were able to get rid of the decimals. You could do the same thing with fractions. You could eliminate the fractions. The way that we eliminated fractions from equations is we multiply by the LCD. So in the top equation, our LCD here is 15. It's going to multiply each term by 15. So 15 times 3/5 x. Okay, this is going to leave me with 9x. 15 times 2/3 give me 10y. I have equal to, now 15 times 1/3 gives me 5. Now let's take a look at the bottom equation. With the bottom equation, our LCD there is 12. So let's go ahead and multiply everything by 12. So 12 times 3/4 x gives me 9x. 12 times negative 1/3 y gives me negative 4y. And now 12 times 1/4 gives me 3. Okay. So I'm left with these two equations without any fractions in it. Okay, let's proceed with our strategy. Let's choose a variable to get rid of. So sometimes it's easier to get rid of one variable over the other. In this case, it might be a little bit easier to get rid of our x's. Because notice the first equation has 9x, the other one also has 9x. So we just need one of these to be negative 9x. The first equation I'm going to keep the same. I'm not going to multiply that by anything. I'm going to leave that as positive 9x. And now the bottom equation, or to get that to a negative 9x, I'm going to multiply by negative 1. So I get negative 9x plus 4y is equal to negative 3. Let's go ahead and add the equations together. So 10y and 4y, that gives me 14y. I have equal to 5 and negative 3 gives me 2. Divide both sides by 14 to get the y by itself. We get y is equal to 2 over 14, which simplifies into y is equal to 1 over 7. Now let's plug this in, plug in 2. So you get to choose whichever equation that you'd like. Remember, it might be easier to plug into one over the other. I definitely don't want to plug it into one of these first two equations because there's a bunch of fractions there. I'm going to try to avoid that. So it leaves us with one of these two modified equations, this one or this one. Let's go ahead and choose, let's choose the bottom one. So let's plug into 9x minus 4y equal to 3. Okay, so we have 9x minus 4 times, and now our y, which is 1 over 7. We have equal to 3. Now let's begin to solve for x. So we get 9x minus 4 over 7 is equal to 3. Add 4 over 7 to both sides. Okay, we get 9x is equal to. Okay, so now the 3 plus 4 over 7, let's work that out over here. So 3 plus 4 over 7. So you need an LCD, so this is really like 3 over 1. So we have to multiply top and bottom by 7, so you get 21 over 7 plus 4 over 7, which gives us 25 over 7. Okay, now, one last step to solve for x. So since it's 9 times x, let's go ahead and divide both sides by 9. Okay. Now remember, you're going to have a fraction divided by a whole number. Let's change this into a fraction as well. So we get x is equal to, okay, so now what we have here is 25 over 7 divided by 9 over 1. Okay, so we have one fraction divided by the other. So what we have to do in this case, let's do some side work. You keep the first fraction the same, change division to multiplication, and then you flip the second fraction. So this gives us 25 over 63. So we have x is equal to 25 over 63, and now we have our x and our y. So we have 25 over 63, comma, 1 over 7. And now we have our solution. Okay. Let's take a look at a couple more. So first equation we have y plus 2x equals 3. Second one we have y plus 2x is equal to negative 1. Let's eliminate our y's in this case. The top equation, let's leave it the same. And now the bottom equation, I want that to be negative y. So what I'm going to do is multiply by negative 1. So I get negative y minus 2x is equal to positive 1. And now in this case, let's take a look at what happens. Y and negative y cancel out. 2x and negative 2x cancels out. So I'm left with 0 equals 4. So in this particular problem, both of my variables canceled out, and I'm left with this statement that's not true. So what we have in this case is no solution. Now going back to section 3.1, the reason why we have no solution is because these are parallel lines. They never intersect each other. So this particular system of equations, there's no solution for. There's no ordered pair that would make both of the equations a true statement. Let's take a look at one last one. So let's choose a variable to get rid of. We have 2x minus 5y equals 10, and then negative 6x plus 15y is equal to negative 30. Let's go ahead and get rid of our x's in this case. So if you take a look at 2 and 6, the smallest number that both of them go into is 6. Now since my bottom equation already has negative 6x, let's try to make the top equation to have positive 6x. So we have to multiply the top equation by 2 in order to get positive 6x. So 3 times 2x gives me 6x, just like what we wanted. 3 times negative 5y gives me negative 15y. And I have equal to 3 times 10 gives me 30. And now the bottom equation. We didn't multiply by anything, so we just kept it the same. Okay. Now let's add the two equations with each other. 6x and negative 6x cancels out. Negative 15y and positive 15y also cancels out. So I'm left with 0 is equal to. Now 30 and negative 30 gives me 0 as well. So something similar happened in this problem as it did with the previous one. Both of our variables canceled out. But now I'm left with a statement that is true. Okay, so in this particular case, we have infinitely many solutions. And the reason why we have infinitely many solutions is because these two lines are the same. These are the same line. So they intersect each other at every single point. Okay. So that was it for section 3.3. If you have any questions at all, just email me and I'll be more than willing to help you out.